Bismillahirrahmanirrahim. Dear students, welcome to PMDC online lecture room. It's Nawaz Khan here, Assistant Professor, Chemistry, PMDC, Hayathabad. Today, we are going to discuss the molecular orbital models of homonuclear molecules. Homonuclear molecules are those molecules which are formed by joining same atoms. For example, H2, O2, N2, Cl2, etc. Now to see first examples of H2 molecules, which consist of two hydrogen atoms, and hydrogen has one atomic number. So its electronic configuration is 1s1. What will be their molecular orbital diagram indication? Let's see. 1s1 and 1s1, these two are atoms now. If they combine together, then they form two sets of molecular orbital, sigma 1s and sigma star 1s. So the two electrons of the 1s orbitals will goes to sigma 1s2 and sigma star will left with no electrons because it is anti-bonding and there are no electron which can be placed in it. So sigma is occupied and sigma star remains incomplete. So what is the bond order? Bond order basically tells us how many bonds can be possible in a single molecules. Now see, in the hydrogen, there are two electrons in the bonding and no electron in anti-bonding. So its bond order will be 2 minus 0 divided by 2. This gives 1. It means there is a single covalent bond possible in hydrogen molecules. Now, to check whether a molecule is feasible or not, a molecule can have a bond or not. This can easily be simplified by formation of He2 model. As helium is a noble gas, it cannot react to form bonds. However, to check the superiority of molecular orbital theory, let's follow the diagram representation. Helium has two atomic number. So 1s2 is their electronic configuration. And these two 1s2 orbitals combine to form bonding and anti-bonding. So there are resultant of 4 electrons. 2 electrons are promoted to bonding molecular orbitals and the remaining 2 are placed in anti-bonding molecular orbitals. And the bond order is 2 electron in bonding and 2 in anti-bonding. If it's divided by 2, then their mean is equal to 0. If the bond order, resultant bond order for each E2 molecule is 0, it simply means that helium molecule cannot be formed. So each E2 is not feasible. Now proceed towards the structure of oxygen. Oxygen has atomic number of 8. Its electronic configuration is 1s2, 2s2, 2p4. Now to check their orbital representation, 1s will combine with 1s to form sigma 1s2 and sigma star 1s2. The 2s orbitals will combine together to form sigma 2s2 and sigma star 2s2. Now 2px will join 2px forming sigma 2px and sigma star 2px. So sigma star 2px will have no electron and the resultant sigma will have 2 electrons. The same is py will join py forming pi 2py 2 and pi star 2py. Now the 2pz will combine with 2pz forming pi 2pz and pi star 2pz. Now, initially there were 2 electrons with the 2px. So, out of the 2 are placed in sigma 2px and the remaining are now lifting. Now, check the antibonding molecular orbitals of the oxygen, that is 2py, pi star 2py and pi star 2pz. Each are now filled with 1 electron, and these electrons are unpaired. So bond order is total number of electron in bonding minus total number of electron in antibonding divided by 2. So there are a total of 10 electron in bonding, 6 electron in antibonding, and their mean value is equal to 2. So bond order for oxygen molecule is 2, which simply means that oxygen has 2 covalent bond in it. And additionally, these 2 unpaired electron in the 2py of pi star of both y and z, these single electron give oxygen an extra behavior that is known as paramagnetic nature. So oxygen is paramagnetic in nature. This is because of their presence of unpaired electron in it. Now proceed towards molecules of nitrogen are in 2 models. Nitrogen has atomic number 7. Its electronic configuration is 1s2, 2s2, 2p3. Now to check the orbital levels, 1s2 will join with 1s2 to forming sigma 1s2 and sigma star 1s2. The 2s will join with 2s to forming sigma 2s2 and sigma star 2s2. Now in P there are 3 electrons, px, py and pz. These 3 separate orbitals have a single electron in it. Remember, the molecular orbital diagram of nitrogen here will be slightly different from oxygen, because in nitrogen there is a triple bond in it, and this triple bond contains 2 pi bonds and 1 sigma. So 2 pi bonds are comparatively more stable than 1 sigma bond. That's why their orbital makeup will be slightly different, because px sigma, that will be high in the energy as compared to pi y. So px will join with px forming sigma 2px and antibonding sigma star 2px. Py will join with py forming 2py and pi star 2pz. 2pz will combine with 2pz forming pi 2pz and pi star 2pz. So in p orbitals there are basically total of 6 electrons, and these all are located in the bonding molecular orbitals. So there is no electron left in the antibonding molecular orbitals. Now proceed toward the bond order. There are 10 electrons in the bonding molecular orbitals and 4 in the antibonding, and their mean value is equal to 3. So the resultant bond order for N2 molecule is 3. Hence there is a triple bonds in nitrogen molecules. Thank you very much.